So, hello sir, good day. My name is Ponciano Ilumabi from ECE 3A of Colegio de Muntinlupa. And in this video, we are going to simulate an FM transmitter using proteus. So first, I'm going to explain what are the components and the processes or functions of each components in here in this circuit. First, in this area, this is a pre-amplifier stage, which is our transistor is BC108, and as you can see, this is an uh, collector to base biased amplifier. So this is R2. It sets the current to the um, collector, and this R1 is a bias from collector to base. So this gives bias to this transistor. Then next, this is C8. This capacitor is a power supply bypass capacitor of our battery, which is 12 volts. And this C1 is a DC coupling capacitor of an audio input. So we used a sine generator or frequency generator as an audio input in this circuit. So it is okay to use any other audio input. Then okay, next, this area is a oscillator commutator stage. There where uh, here see the capacitor 2, it is a uh, coupling capacitor from first stage, which is a preamplifier, to the second stage, which is the uh, oscillator commutator. So here we can see that this is a voltage divider circuit where R3 and R4 are responsible for the bias of this transistor, which is 2N2369. So these are the biasing resistors. So the R5 is the resistor from the emitter. Then here, uh, the inductor 1 and the capacitor 5, these two are responsible, or these two are needed, or the reason of the oscillation of this circuit. So this is the reason of the FM signal. So the capacitor 5 and the capacitor 6 are actually trimmer or variable capacitor, but here in proteus, the variable capacitor and the trimmer is not applicable in simulating. So I used uh, fixed resistor and sets the value of each, so to be able to simulate this circuit in proteus. So here, as you can see, the output or the FM signal is connected to the collector of this transistor and to the antenna. So before going to the antenna, it goes through capacitor 9, which is the uh, coupling capacitor, or it couples the FM signal, the output of this um, transistor, to the antenna. So this is the um, circuit. So we are going to simulate this now. Then here. So this is the audio input, the input signal, and this is the uh, output or the FM signal in here in oscilloscope. So we are going to get the um, Fourier analysis and the frequency spectrum of this circuit. So for frequency spectrum, okay, yeah, and for your analysis here. Okay, so let's set this properly to be able to see the the waveforms of the signals. So here for your analysis, just right click, then add traces, and set the probe P1 to C92. So here it is. I used a um, voltage probe to be able to uh, get the Fourier analysis. Then here, set the reference to sine generator, which is the audio input, then add traces, then the output FM signal. Okay. Then we're going to simulate here. So then here it is the Fourier analysis and the frequency spectrum. Okay. We are going to set this to 150 mega and simulate. Yeah, so here it is the frequency spectrum and the Fourier analysis of this uh, FM transmitter. Here it is. Then debug. Then so here it is. That's all for this video. Thank you for watching.